Now this illustration deals with individual circuits, in this case branch circuits, in accordance with NEC 210.19A1A is in Apple, and that's using the 125% rule for continuous duty plus non-continuous duty. A1B deals when we have correction factors and adjustment factors involved. Now, in the calculation that we're reviewing now, we do not have any correction factors or adjustment factors. Now, with that information, we're now ready to move to the calculation to the left in the illustration. Step one, we have a question first though, so let's look at that. What size overcurrent device and THW copper conductors are required for the branch circuit? Now, step one, if we're sizing conductors, naturally we review 210.19A1, and it would be the 125% rule for continuous duty because we have no adjustment or correction factors involved here. So we would take 11 amps at 125%, and we would come up with 13.75. Now notice conductors and overcurrent device are shown here. And the reason for that, the conductor sized at 125% for continuous load, as we said previously, derates the loading or reduces the loading of the overcurrent device 80%. Now, the two loads that we have non-continuous, 3 amps each added together, is 6 amps times 100%, so we come up with 6 amps. Now, when we add the two loads together in step one, we have a calculated load of 19.75. However, the connected load would be naturally 17 amps, is basically what we would be reviewing there. Now, step two, table 310.16, along with the requirements of 240.4B that allows rounding up procedures, 240.4D that classifies small conductors as number 10, 12, 14, 16, and 18 when reviewed. So 19.75 amps requires a 20 amp overcurrent device with number 12 wire when you review those with the table and the sections I just previously mentioned. So in the solution, the answer is a 20 amp overcurrent protection device and number 12 AWG THWN conductors are required. And notice the above calculation and the note states there's not any adjustment or correction factors. So as designing engineers and electricians say, this circuit is routed through an area of paradise because we do not have to worry about correction factors or adjustment factors in any way. But now when we review to the right, we're going to look at it where we have adjustment factor or correction factor involved. So let's review now the illustration and boxed in information to the right of the illustration. Another question is asked. What size overcurrent device and THWN copper conductors are required for the branch circuit based on the ambient temperature of 135 degrees Fahrenheit? Now we're routing up close to the roof area, some like that type of installation where the heat could be very great maybe. But the main point is we're routing through more than 10 foot of the run or 10% of the run through a higher ambient as illustrated with requirements and 310.14, I believe it's A2 exception that we'd get into for that rule. Now, notice everything in step one in accordance with 210.19 A1 little b is taken at 100%. Continuous load, non-continuous load, even demand factors. If we have demand factors. Say we had a demand factor of a certain load of 65%. Well, that'd be 65% of the total load times 100%. That's what this step 1 is illustrating. So we come up with 17 amps, as I quoted to you, as the connected load in step 1 to the illustration to the left. Now we apply from table 310.15 C1 as in car from the 90-degree column now for that wire. We would select 30 amps from table 310.16 for number 12 from the 90-degree column in table 310.16 based upon the THHN. Now remember, we said earlier in this presentation that you could review 110.14C along with 334.80, and the 90-degree permissive rule is allowed to be used. And basically, engineers, when they learn this, or electricians, either one, they know the 90-degree column does not exist until adjustment factors or correction factors are applied. We only have the 60 and 75-degree column where devices, terminals, lugs, equipment would match up. We do not have 90-degree equipment in most all cases. Now, when we apply then that 71% from our table 310.15C1 using number 12 THHN copper conductors, 71% would be selected based upon the 135 degrees Fahrenheit that we place in a group of temperature ratings from our table 310.15, C as in car 1. So after the application of the 71% times 30 amps, we come up with 21.3 amps. Now the question is, has to be applied. Will the 21.3 supply the 17 amps? Yes. Will the 21.3 amps be permissible to be connected to a 20 amp overcurrent device for 240.4D as in dog? And the answer is yes. So the answer in the solution is a 20 amp overcurrent device ahead of number 12 wire supplying that branch circuit. And that's what figure 8-18B is illustrating for the user of the NEC.